Welcome to my 2021 PHUSE European Connect presentation, How to be Traceable in Adam, where I'd like once again to reinforce the importance of traceability and in particular in the Adam packages and the documentation provided with it. This is the agenda with the summary of topics I would like to cover today, starting with the introduction to traceability. Then I will provide some examples of how to achieve traceability in Adam, and I will also provide some basic example on how to verify Adam traceability programmatically. Let's start with the introduction of traceability in CDISC. For those that are not yet familiar with the concept of traceability, I will use the CDISC definition and an excerpt from the FDA Study Data Technical Conformance Guidance. CDISC says that traceability is the property that enables the understanding of the data lineage and or the relationship between an element and its predecessor. Traceability is built by clearly establishing the path between an element and its immediate predecessor. While the FDA in the Study Data Technical Conformance Guidance says that by talking about traceability, says that establishing traceability is one of the most problematic issues associated with any data conversion. If the reviewer is unable to trace study from the data collection of subjects participating in a study to the analysis of the overall study data, then the regulatory review of a submission may be compromised. So the last part of the sentence look like, if not yet a treat, at least a warning. But actually, more than once FDA members have sent a clear message in public speech, like the CDISC interchange a few years ago, about how important it is for them traceability. And actually, one of this FDA reviewer, biostatistician, says that for him, the traceability is even more important than standard itself. But how can we, in practice, achieve traceability in our Adam data packages? Well, technically, in Adam, traceability can be achieved in two ways, through data points, or through the data, and through metadata. Data point traceability by, for example, copying the sequence variable from the SCTM source dataset. Like here in the example, a record in the ADIE dataset, it's linked to its predecessor record in the SCTM dataset by keeping essentially in the ADIE dataset the ASIC variable. Of course, there is more than that, as we'll discuss in a few minutes. Together with data point traceability, or whenever data point traceability it's complex to implement, we can achieve traceability through proper use of metadata. So essentially in CDISC, this means by having a good defined XML, where, for example, like here, we have, of course, to clearly describe in English the algorithm that we use for deriving a particular topic, a variable. So the Adam implementation guidance provides several examples on what other methods you can use to maintain data traceability in your Adam dataset package. If an Adam dataset is well designed by applying the applicable Adam rules and best practices described in the Adam implementation guidance, then by just opening an Adam dataset, a reviewer should, to a certain extent, of course, understand what kind of transformation have been made to which data. This can be achieved through other more sophisticated data point traceability technique. For example, when you need to rederive in Adam a variable already collected, already derived in SCTM, for example, age, you should create a new variable. So you should not override the original value of age coming from SCTM. And similarly, and of course, the recommendation is also to keep the original variables from which the new age has been derived. Similarly, when you need to derive a variable using variables from SCTM, you should keep the original SCTM variable used in the derivation. When you need to impute a missing or a partial date, for example, a partial value, for example, date, you should create a new variable in Adam and keep the original SCTM variable. For datetime variable, you should also make use of imputation flags variable so that it is clear for which part of the date you apply an imputation. When you need to apply time windowing methods, for example, visit, you should create an analysis visit variable, for example, and keep the supporting Adam windowing variable. So there are some special variable to describe how you window an observation. And also you should keep the original SCTM time points, in this case from SCTM, so visit and visit num. When you need to impute missing time points from other time points, for example, a missing visit, you should derive a new record, and you should keep the original time points record even if not analyzed. So the record from which the missing visit has been imputed using, for example, method like last observation carry forward. You should also, in this case, make use of metadata of standard Adam flags to identify records, or in this case, visit used in the analysis versus those that are not used. When you deal with complex derivation requiring several steps, it is recommended to make use of intermediate dataset. The following two references contain good example of use of intermediate analysis dataset. In particular, the breast cancer talk contain a specific chapter called the intermediate event dataset, where the intermediate event dataset in this particular case, it's a dataset where all data that might contribute to the derivation of a complex time to event endpoint are stored and used as a source for another Adam dataset where the actual time to event endpoint it's derived. So to summarize, how technically you can achieve traceability with the rules and best practice recommended in the Adam implementation guide. Well, first of all, have a good metadata in place through define XML. And if this is not sufficient, add additional details as appropriate in the analysis data reviewer guide. Of course, the statistical traceability starts, I would say, from the protocol, but in our case, starts from the statistical analysis plan, where you should also provide, they should also contain details and full rationale of the reason why you needed some transformation. Traceability in Adam might also require metadata for analysis results, although this is not yet mandatory. For example, for all agencies. For example, FDA is currently not requiring the analysis results metadata, but this is still a good practice. Furthermore, it's still good practice to keep the original, as we just made an example before, to keep the original variables and original CTM records in your Adam dataset, and the sequence variables, and make use of other standard Adam variable to denote special cases such as I mentioned before, date imputation or record imputation / let's say derivation, or make use of any other standard flags available in Adam to flag a special case. And as discussed before, for example, when you have to deal with the complex and when you have to deal with the complex transformation, make use of intermediate analysis dataset. Let's now look at some traceability examples. As I previously said, the Adam implementation guide contains a number of examples of best practice to make sure our Adam datasets are traceable enough. To provide more use cases, the CDISC Adam team should release at the end of this year a document where additional example of traceability will be provided. The document has already went through a public review process, and its contents presented already in a couple of events. The document was out for review earlier this year, and among general recommendations such as what is the optimal number of analysis dataset, how to be analysis ready, etc., it contains 12 instances of fully explained metadata samples together with outputs and Adam dataset examples, such as general dataset traceability. We'll have an example in the next slide. Traceability with parameters from multiple input dataset, for example, when the derivation of a study endpoint requires variables and record from multiple input STM or Adam dataset. Traceability when multiple datasets are merged together. Traceability when input dataset are staked to create an occurrence dataset like ADIE. Traceability when using a lookup table, for example, when in addition to SCTM and Adam dataset, our derivation make use of, say, non-subject data, and therefore you make use of an additional dataset containing information to further to apply derivation classification based on criteria that might require lengthy if then else, typically SNQ assignment for diverse events. Traceability when adding a row to a BDS dataset. I will show an example later on. Traceability when multiple analysis variables are needed on the same row, for example, for statistical analysis methods featuring multiple independent or dependent variables. Using an intermediate dataset for BDS traceability or using an intermediate dataset for adjacent traceability when dealing with complex and articulate derivation. I just want now to provide two examples, one pretty simple and one a bit more complex. The first one is for general ADSL traceability. So let's assume in this example we want to derive in ADSL because we need it in our demographic table the age in category as per the derivation detailed in the statistical analysis plan. I would need to get from the SDTM dataset the date of birth and the randomization date and the age. It could be that the statistical analysis plan has a definition of age that does not match the age either entered or derived in SDTM. In that case, we will need to create a new variable age in ADSL, but for traceability purpose, as said before, and for the other fundamental principle, we will not change the original value, so we will not change the original age variable from SDTM, but instead we'll create a new variable and name age to say analysis age, from which then we will derive our age in categories. If instead we are happy the way the age has been either collected or derived in SDTM, the variable age in category will make use of the original age variable from SDTM. The second more complicated example, it has actually nothing to do with ADSL traceability as erroneously mentioned in the title of the slide, but it has to do with the addition of new records in ADAM when using the BDS ADAM class. In this example, we need to derive a study primary efficacy endpoint defined as the weekly mean pain intensity score. And in doing that, we already apply some windowing criteria where we have defined the analysis visit, for example, based on the relative day, based on the variable ADI. In deriving the weekly average, we'll need to exclude observation where the subject was still in the washout phase, where essentially it was still making use of other drug to cure its pain. The observation in this case occur in the washout period are kept in the ADAM dataset as well as any other original record from SDTM, but they are flagged with an analysis flag. So in this case, analysis flag will be null. And instead, to represent the weekly daily pain average score, a new record, in this case, a new parameter is derived instead of adding new variables to the dataset. This is to preserve somehow the standard BDS structure. And of note here for the purist, for the ADAM purist, we could have avoided the use of the type and simply we could have described the algorithm in the defined XML, but that's a minor deviation, I would say. What we saw before was a good example of full data traceability achieved by applying different ADAM techniques. This is a good example of ADAM dataset where, as I like to say, the reviewer could understand what we did by simply opening the ADAM dataset. But because we want to be sure what we did it's fully traceable, and therefore we want to be transparent with the reviewer with the method and use for transforming our data for analysis purpose, we also provide the derivation methods we use to derive our new parameters. And this will be, of course, done in the defined XML. And as I said before, we could also provide additional details in the reviewer guide if defined XML has doesn't allow enough space for providing the required details to fully understand what we did. And when creating data submission packages, for example, in this case for ADAM, we need to try to get to be in the shoes or in the brain of the reviewer and anticipate as much as possible its thinking. And therefore, the step he or she will follow, the reviewer will follow in assessing our packages while trying to reproduce what we did. So analysis results are metadata that are specific part of the defined XML, specifically specific for Adam, even if not mandatory by all health authorities, can be a good start for our good traceability objective, where at least the key analysis results are described by specifying the object of the analysis, the analysis variable used, and why not the source code snippet in this case, in this specific case, with the exact details of the analysis method used, so that the reviewer will be able to eventually either reproduce or choose another, another alternative, another method. Furthermore, because we really want to be sure what we did is clear enough, we could provide more similar details in the analysis data review guide by, for example, highlighting the fact that in the specific example, the Adam dataset ADPP contained the primary and secondary endpoint. And moreover, we wanted the reviewer to be aware that this specific study, one derived variable, the geometric mean, was actually not calculated in Adam, but in the output program. An alternative to analysis results metadata, a good approach would be, as per this specific sponsor analysis data reviewer guide template, to describe the key study endpoint analysis by providing and describing the source analysis program and which Adam dataset have been used, and eventually the selection criteria that we have applied. I mentioned earlier how important it's for the reviewer to receive traceable data packages, and often health authorities during public events such as the CDISC interchange provide in the past feedback on the quality of data packages received. One very famous example back in 2012, and afterward, in a few instances, was the FDA CDISC top 7 CD standard issues, and that the focus was more on the STM packages. But more recently, the past CDISC European interchange last April, the FDA also shared some very detailed assessment of Adam traceability in the submitted Adam packages they have received so far from various sponsors. And again, in their conclusion, they have stressed the fact that some of their finding in the traceability assessment they made could call for question and might result in an information request letter to be sent to the sponsor. So, in summary, another warning from the agency. As the last topic of my presentation, as somehow promised in my abstract, I would like to quickly touch the topic of how we can make sure our Adam dataset are conformant, of good quality, and traceable enough. So we often stress during the Adam training the importance of the assessment of the Adam dataset conformance to the standard. I would not discuss it here, but it is important to say that a lot of the conformance assessment in Adam depends on subjective assessment. That means we need a solid process to internally validate and review, and hopefully independently, the Adam package. And it's the defined XML and the reviewer guide. And as for the objective assessment, CDISC with all standard provide the so-called conformance rules, through which we can create tools to validate the conformance of our data packages. And with regard to the Adam conformance rules pertaining to the verification of the Adam traceability, CDISC has defined 13 checks, which essentially makes some basic verification between some Adam dataset and some key STM dataset, such as DM, EX, and AE. This is, of course, not enough, and more checks should be put in place to verify traceability, and I would say consistency, for example, between STM and Adam packages. For example, a check that is not often made and it is not available in the current standard CDISC validation tools, it is the consistency between STM and Adam, by making sure, for example, that what is reported in the Adam defined XML is correct. A typical example is when the origin of another variable is its predecessor, meaning that in this case, the variable was copied as it is from the source STM dataset, in this case, EG. We therefore need to make sure variable attribute were not changed, as well as its content. But most important is that the variable exists in the predecessor SDTM dataset, so that, if you would, so that also the predecessor variable attribute, for example, maybe was misspelled in the define XML metadata for Atom. Of course, probably a good metadata repository tool, if well implemented, should guarantee such traceability more or less automatically between SDTM and Atom. Or things like derivation method would be instead more complicated to be verified programmatically, of course. So here, manual independent review, as I said before, it's still needed. Another example of traceability we could easily check programmatically is when variable from ADSL are copied onto other Adam dataset. Again, the same we discussed before for SDTM predecessor should be guaranteed here within Adam dataset, and this is just a simple macro that could simple code snippet that could help to verify that the variable copy from ADSL to other Adam dataset are not change of value. Reaching the end of conclusion. So good Adam traceability could avoid misunderstanding and question from the reviewer. When traceability is successfully implemented, it is in fact possible for the reviewer to identify things like information that exists in the submitted SDTM data, information that is derived or imputed with the Adam dataset, the method used to create, derive, or imputed data, and information, records, visit, etc. used for analysis, in contrast with those that are not used for the analysis, but yet included in the Adam dataset for traceability purpose or for future analysis. Traceability could also, of course, facilitate automation of our processes. And after all, traceability, if you want to add a third definition to the two I mentioned at the beginning of the presentation, it is for me the heart of making complex things simple, clear, and transparent. Some useful reference here for further reading, if you to elaborate on a bit more.